Interstellar objects. It may just be one of the most intriguing recent discoveries in planetary science. Scientists have only had limited access to these objects once they've been detected, but that is about to change thanks to NASA's James Webb Space Telescope. But how exactly can the JWST aid in knowing more about these fascinating discoveries? What interstellar objects were found to this date, and what more can we discover in the future? Ready to know more? Let's dive into it, shall we? The supreme sensitivity and power of Webb now present us with an unprecedented opportunity to investigate the chemical composition of these interstellar objects and find out so much more about their nature, where they come from, how they were made, and what they can tell us about the conditions present in their home systems. It is definitely safe to say that the ability to study one of these and find out its composition, to really see material from around another planetary system close up, is truly an amazing thing. The first two interstellar objects discovered were quite different. One looked like a comet, and the other didn't. First up is the Oumuamua, discovered in 2017. They spotted an interstellar object in our solar system and named it Oumuamua, a Hawaiian term for scout. First, astronomers thought it was a comet, but no trace of comet-like activity was detected when it swung around the sun at speeds of 196,000 miles per hour. Then, astronomers thought it was an asteroid until further measurements detected something that didn't seem physically possible. This object from another star system was accelerating, and natural rocks in space rarely speed up independently. The science community bubbled with excitement as theories mounted that this might not be a comet. Instead, this might be an alien artifact, like a probe or a derelict spaceship from another civilization. The second one is Borisov, discovered in 2018 as it streaked into the solar system. The comet's speed and trajectory revealed it was a rogue comet from interstellar space, making it the first known interstellar comet and the second known interstellar visitor after pancake-shaped Oumuamua. The scientists discovered the light from Borisov's coma was very polarized, suggesting it was more pristine than other comets. That is, its surface rarely bathed in light and winds from stars. The only comet that previous research found had light as polarized as the interstellar visitor was Hale-Bopp, which lit up Earth's sky in 1997. These two discoveries provide scientists with a tantalizing view into distant planetary systems. However, because these objects emerge in unpredictable ways, astronomers must rush to collect as many observations as possible while they are close enough to investigate. Fortunately, NASA's JWST is expected to expand that timeframe. Astronomers are constantly monitoring a variety of sources of data, ranging from amateur observers to professional observatories, in the hopes of discovering the next interstellar visitor. When the next such object is first detected, scientists won't immediately be certain if it's an interstellar object. They'll need additional observations over a period of days, weeks, or even months to confirm it, depending on its brightness. They can compute the object's track across the sky once they've confirmed that it came from beyond the solar system based on its hyperbolic orbit, and that it didn't come from far limits of our own solar system or the Oort cloud. With Webb, we can do really interesting science at much fainter magnitudes or brightness. Gathering and interpreting infrared radiation is a special strength of the James Webb Space Telescope. Because heat interferes with infrared detections, The observatory must be placed so distant from Earth and have such sophisticated sunshield. However, experts believe that the infrared detections will be worthwhile even for interstellar objects. Basically, the team would use infrared observations to study any gas and dust that the interstellar object is emitting, giving scientists a taste of the object's native system. Who knows? It might have been from another alien civilization that might just be our neighbors, right? To study two different aspects of the interstellar object, the team will use Webb's spectroscopic capabilities in the near-infrared and mid-infrared bands. They will first examine the chemical fingerprints of gases released by the object using the near-infrared spectrograph, or NIRSpec, as any ices present are vaporized by our sun's heat. Second, they will use the mid-infrared instrument, or MIRI, to look for any dust that the object is producing, including microscopic particles, larger grains, and even pebbles that have been lifted off the surface and are encircling it. NIRSpec's high spectral resolution allows the team to detect specific molecules such as water, methanol, formaldehyde, carbon dioxide, carbon monoxide, and methane. Thanks to its high spectral resolution, MIRI, in the mid-infrared, is more tuned to the heat spectrum produced by solid particles, such as dust grains or the object's nucleus. Because interstellar objects have never been observed in these important near and mid-infrared wavelength ranges, the potential for new discoveries is enormous. The team has no idea what they will find among the trillions of interstellar objects buzzing around the galaxy. But they will know it will be fascinating. Studying interstellar objects like Oumuamua and Borisov using the tools made available by the James Webb Space Telescope could connect eternal questions with long-sought answers. Among those are mysteries on how planets form from basic chemicals, whether the way it happens is universal, and whether our solar system is a notable exception of how planets generally form elsewhere. In turn, this could reveal how life comes to be in the universe, and possibly constitute a major hint about where and when we might find alien life in the galaxy. Webb will help us find out and solve mysteries in our solar system, look beyond to distant worlds around the other stars, and probe the mysterious structures and origins of our universe, and our place in it. So the next time an interstellar object pays a visit, astronomers will be better prepared for it, thanks to Webb.